Hello guys, welcome to the fourth video of the playlist Google Earth Engine for the beginners. In today's video, we will learn about the digital elevation models, short for DEM, and through this we will know the elevation of any place or the region of interest, and what are all the products that can be derived from the digital elevation model, like the slope aspect, and we will also visualize the slope of a terrain through Hillshade. So let's start by importing the digital elevation model. So let's search DEM. That's the digital elevation model. You can here you can see there are various data for the DEM, including the merit data from the Copernicus as well as the Australian DEM. This Australian 5-meter DEM is only for the Australian country. So instead of searching digital elevation model, let us search as NASA SRTM. Yeah, NASA SRTM digital elevation 30-meter data. So open the data set. The SRTM stands for the shuttle radar topographic machine, and it is consisting of the bands elevation ranging from -10 to 6500. The resolution is 30-meter and the units are in meters. So let's import this, and the data set available is the 2000 only. So import and rename it as data. Okay, and now let us filter our data set by creating a variable dem is equal to, we will select our data first, data dot let us create one region of interest simply for our reference, and change the settings, uh, rename it as region of interest. So in order to know more about how to create a shapefile, please go through the previous videos, and import it as a feature collection because it's a vector data, and any vector data in the form of feature collection will be easy for the analysis. And property you can add if you want. We will simply add id 1 and click OK. So yeah, here you can see our region of interest is imported, and now uncheck the geometry, and let us clip our data to uh, region of interest using the function clip, and let us visualize our digital elevation model by using the function map.add layer dem, and set the visualization parameters for default and rename it as digital elevation model, and click on run. So here you can see the layer is loading now. Okay, so let's change the range of the band reflectance from 10 to 750. It is the minimum as well as the maximum that our particular dataset has for our region, and let's click apply. Yeah, so let's use the inspect column, and let's see what the elevation at this particular point of interest. As you can see, the 445-meter above mean sea level, it is the elevation at this point, and if I'm not wrong, here you can see this is the water. So let us check at the water levels. So there it is, the 48-meter from the mean sea level. So we can also use the color palette, like for low elevations let's use red, and for medium elevations let's use white, and for the dark elevations let's use green, and click on the apply. So yeah, here you can see the green color appears to be more elevated than the red and the white color. So if you want, you can import this uh, visualization parameters and rename it as dem viz, and replace this flower brackets through dem viz. So now if you give run directly, it will come in its range and the palette which we have given. So yeah, so now we will see how we can derive the products from the dem. So first we will see how we can calculate the slope. So variable slope is equal to, select our dem data, and use not dem data. So let's write the function e dot terrain. So this is the function which is used for calculating the slope, e dot terrain dot slope. So e stands for Google Earth Engine, and the terrain stands for we are deriving the terrain features so from the digital elevation model, and the slope indicates we want this particular product from the elevation. So open the brackets and give our dem as an input, and let's add this also to our layer through the use of a function map dot add layer slope. Okay, then leave the visualization parameters for default and rename it as slope. Okay, so give run. Okay, I missed the L O slope. Okay, so yeah, so clearly you can see the slope layer has been loaded. Let's see what its range, and the units are in degrees, of course. So if you want to know the degrees uh, or the unit of any products, you can go to algorithm. So here you can see uh, I have used e.terrain.slope, and we are giving the input any image with the elevation bandwidth be there, and the output will be an image. Okay, so let's stretch the range of the slope band. As you can see, the slope is ranging from 0 to 26 degrees, and you can also change the palette now. Let's use the similar palette, red, okay, white, and yellow this time maybe. Okay, click apply. So yeah, here you can see again the water bodies has no slope, and it is depicted in the red color, and white colors also indicating the medium slope. So like this we can also derive the aspect through the use of the function e.terrain.aspect. So let's create one more variable as variable aspect is equal to e.terrain dot aspect. Okay, so give our elevation as input again, and let's add this layer also to the map, and see what's the aspect at a particular point. So we are adding our aspect variable to the map and leaving the visualization parameters for default and named as aspect. Okay, click on the run now. So yeah, clearly you can see the aspect is the direction the slope faces, and the slope is the steepness or the angle of the terrain. So here you can easily see to which direction does the terrain faces towards and the slope faces towards. And we can also have one more parameter that is called as the hillshade. So it is also one of the product of the digital elevation model only. So we are using the same function again, and give our elevation as the input layer. So map dot add layer hillshade, and rename it as hillshade. Okay, click on the run. So here we have the four layer. The DEM stands for the elevation, slope, aspect, and the hillshade. So on in general, the hillshade is a technique used in the uh, topographic mapping in order to simulate the appearance of sunlight and the shadow of a terrain. So let us stretch this range also to 100% and click on the apply. So yeah, the hillshade is usually used for only visualization. It has no other analytical value as of my knowledge. So in order to derive all these parameters at once, we have one separate algorithm which is called as let's call this variable as variable products is equal to ee dot algorithms dot terrain, and give our dem as a input, and add this layer dot map add dot layer. So products, okay, dem products, let's name it as a dem products. Okay, now click on the run. So we have 5 layers. The first dem layer is indicating the elevation, and the next is slope, aspect, and the hillshade, and our final layer, that is the dem products. It is it has all the variables which I have derived now. So if you can open it, so let us check to the inspect column only. So here you can see the dem product has all the 4 bands which I have calculated earlier singly. So if you want, you can calculate separately, or else you can calculate through algorithm function dot terrain, and give any digital elevation model containing the elevation as a input. So you will get these 4 products. So uh, that's it guys for today. Thank you for watching, and keep sharing. Thank you.